Welcome to aminacademy.com. In complex numbers regarding properties of moduli, let us discuss about the property 8. Modulus of z1 plus z2 is lesser or equal modulus of z plus modulus of z2. Here, let us prove it. Now, z1 plus z2 whole square equal, we know that z1 plus z2 into z1 plus z2 of bar, which is further equal z1 plus z2 into z1 bar plus z2 bar. These are properties. Next, we can distribute this like z1 z2 bar plus z1 z we write first z1 by multiplication z1 bar plus z1 z2 bar plus z2 z1 bar plus z2 z2 bar, which is further equal z1 bar plus z2 bar, then plus combining that z1 z2 bar plus z2 and z1 bar. Now, instead of z1 bar is z1 is here, z1 bar is z1 modulus square plus z2 modulus square plus z1 z2 bar plus z1 here is z1 and z2 bar whole bar. Since because we have the rule z1 z2 bar equal z1 bar into z2 bar, and we have z1 whole bar equal z2 properties we used here. Next, z1 bar square plus z2 bar square equal to real part of z1 plus z2 bar. Since z1 plus z2 bar equal 2 times real part of z. Now we can write which is lesser or equal to lesser or equal with z1 square plus z2 bar square, z2 square, plus 2 into z1 z2 bar. Why? Because since a is lesser or equal square root of a square plus b square, therefore we can say the real part of or complex number a plus bi can never exceed its absolute value. Its absolute value, that is real part of z is always lesser or equal to z. Therefore we can continue like modulus of z1 plus z2 whole square is lesser or equal to z1 modulus of z1 square plus modulus of z2 square plus 2 times z1 into modulus of z2, which further gives z1 plus z2 whole square lesser or equal z1 square plus z2 square plus 2 into z1 z2. Since we can say z bar is equal to modulus of z. Modulus of z bar is equal to modulus of z. Therefore, which gives further z1 plus z2 whole square is lesser or equal z1 modulus plus z2 modulus whole square. Since z1 square, that is modulus z1 square plus modulus z2 square plus 2 into modulus of z1 and modulus of z2 is equal to modulus of z1 plus modulus of z2 whole square. Taking positive square root both sides, taking positive square root both sides, we can get z1 plus z2 is lesser or equal modulus of z1 modulus of plus modulus of z2. We can note some point here. The above inequality can be extended for n complex numbers, means for z1 z2 z3 blah 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 zn, we can have the result like modulus of z1 plus z2 plus z3 plus dot 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 zn is lesser or equal to individual modulus of z1 plus modulus of z2 plus modulus of z3 plus modulus of zn.